Now let's examine the wave function. The Gaussian part of the wave function pretty much guarantees that your function is well behaved, because when you have that e to the negative x squared term, okay, over alpha, what's that, negative x squared over alpha? Over 2 alpha squared. Okay, it's just negative e to the negative cx squared, right? That's a Gaussian. What does a Gaussian look like? A bell curve. And where's the peak of the curve? At x equals 0, right? So at x equals 0, so you have that. So it exponentially drops as x increases. Okay. So e to the negative x squared. So that's the Gaussian function. So what the Gaussian function factor does in your overall expression for your wave function is it guarantees that your wave function goes to 0 as x goes to positive or negative infinity. So when x becomes very large, positive infinity or negative infinity, the Gaussian function approaches 0. That guarantees that your function is normalized. Right? What would be the polynomial part? What did we say the degree of the polynomial is going to be? Whatever v is, right? So for v equals 0, what's our polynomial? Constant times x to the power 0, and that's it. So it's just going to be a constant. So that the polynomial term really there is just a constant. What about when v equals 1? Constant times x to the 1 plus another constant times x cubed. Oh, that's it. X to the 1. Order of the polynomial. So it's just a constant times x. Now this c right here and this c are not the same. Okay, so I'm just using a generic letter there. For v equals 2, what would your polynomial look like? So constant times x to the 0 plus another constant times x squared. You're only going to get even powers up to whatever v is. So to distinguish between these two constants, I'm going to call this first one c0, and I'm going to call the second one c2. So your function is going to be c0 plus c2 x squared. Okay, that's the polynomial part. What about v equals 3? What's a polynomial factor going to look like? c1 x to the 1 plus c3 x cubed, where c1 and c3 are constants. Okay. For v equals 4, what's it going to look like? c0 x to the 0 plus c2 x squared plus c4 x to the 4th. Fourth degree polynomial. V equals 5. Polynomial is going to be c1x plus c3x cubed plus c5x to the 5th. All right. So you're getting it? Getting the pattern? All right. Now, it's the polynomial part that gives rise to nodes in your wave function. Okay? Remember, what's a node? Do you remember what a node is? That's when your function goes to 0, right? At the node, your wave function changes sign from positive to negative. That's when it crosses 0. Well, the number of nodes is just going to be equal to v, whatever v is. Why is that? Well, let's go back to our polynomials. For how many x values will you get this thing to be equal to 0? Quadratic expression highest power is 2. So this has 2 zeros, right? That will give you 2 nodes. V equals 3. There's 3 possible values of x that will give you a node. That will, where the function is going to be equal to 0. So a number of nodes is just equal to v. So here's an example. For v equals 2, Okay, the Hermite polynomial, the polynomial part of your wave function is given by 4y squared minus 2, where y we said is x over alpha. So where would these nodes occur? When 4y squared minus 2 is equal to 0, y is going to be equal to, what would it be? 2 over 4. Y squared is 2 over 4. So that would be 1. Plus or minus square root of 1/2, right? So if I were to sketch the wave function for this, what would it look like? I were to sketch psi versus x. And let's sketch it versus y. Okay. At y equals plus or minus 1 over square root of 2. What's 1 over square root of 2 numerically? Square root of 2 divided by 2. Get that on your calculator? Square root of 2 is about 1.4. Okay, 0.71, okay? So y equals 0.71. So if this is 1, so 0.71 is over here, you're going to get a node. So there's a node at y equals 0.71. And where's the other node? At y equals negative 0.71, right? All right. So that's where your node is. What does the function do as x approaches infinity and negative infinity? It goes to 0, right? Now, for v equals 2, okay, is that an odd or an even function? Even function. So in other words, I can say then that if my function goes to 0 like this, as y approaches positive infinity, what would it look like as y approaches negative infinity? It's going to be symmetrical about the y-axis, right? So it's going to look like this, right? Now, if it has a node at y equals 1 over square root of 2, that means this function is going to go back down there, right? Cross over from positive to negative and then go negative. And then if this is a node over here, then it has to go back to 0 there, right? Cross over, go positive, and then eventually it's going to go back down towards 0. So that's what your function would look like. Your function would have two nodes, 1, 2. It goes to 0 at y as y approaches infinity. It goes to 0 as y approaches negative infinity. Okay. What values of x would this actually correspond to? Well, how is this going to be at x equals y alpha? So if this was an x-axis, then this would be this is going to be alpha, and this is going to be negative alpha. Right. So that's what the sketch looks like. And here are the functions from your sketched in your textbook. Okay, so here's v equals 0. It's just a Gaussian. Your polynomial is just a constant. Right? V equals 1. What do you have? How many nodes do you expect for v equals 1? One node. The node is right there at the origin, so v equals 1 is this one right here. Okay. Note that all of these functions go to 0 at positive and negative infinity. What about v equals 2? V equals 2, you have one node, two nodes. So here's your function. Goes to negative infinity that way, and goes to negative infinity that way. Am I missing something here? I picked the wrong one. I picked the wrong one. Okay. So this is the node right here. Goes up. You can see it's symmetrical around the vertical axis, right? And then, so there's your two nodes right there. For v equals 3, you're going to have how many nodes? 3 nodes. So for v equals 3, the origin is going to be a node, and then you've got 2 nodes around that. So 1, 2, 3 nodes. Okay? And where's v equals 3? There's your node right there at the origin. And there's another node right there and another node right there. So v equals 3. There's 3 right there. 1 node, 2 nodes, 3 nodes, and then goes back down, goes back to 0 as y approaches positive infinity, goes back to 0 as y approaches negative infinity.